Okay, so I'm going to show you Stata first. So this is the Stata shortcut method of doing moderation. Now, again, censoring is optional if you wanted to do that, but the real meat of it is going to be these three lines here. You run a regression, and we have some new syntax here that you're going to pay attention to, and then you're going to probe the interaction. Okay, so let me show you how that would work. Okay, so here is in the steps in data analysis handout. We are in the moderation section. I gave you two examples of code. This is in option 3, run with the Stata shortcut. You have two examples of code here that you can use. The first example is, the only difference here, let me just show you. The only difference here is what happens after your two pound signs or hashtags. This is regress, our dependent variable. So we're gonna have stir craziness here on our continuous variable. So if we have a continuous variable, that's where we use, remember many weeks ago, I showed you the C dot and I dot, that's where this comes in. If you have a continuous variable, you put a C right there. So C dot days in isolation, yeah. And then you do your two pound signs. That means you're going to be interacting these two. And then if it's a multi-categorical variable, say like race, then you would do I dot. But since this is a variable that only has two categories, we can just have the variable name itself, extrovert. Okay, so take a look at this again. Our dependent variable, C dot days in isolation, because days in isolation is a continuous variable. Two pound signs or hashtags, which means that we're interacting them, and then extrovert. That tells us that extrovert is a variable with two categories. All right, now when we run that, Stata, which is over here, does this. Is our code again. It looks like a regression, right? It's the same thing we've been doing. Okay, so we have our sums of squares, we have our R squared here. And then we get our variables. So just to know how Stata is going to lay this out for you, it's going to put your continuous variable here, right? So it just looks like that, days in isolation. And then it has our categorical variable, extrovert. Then this is going to be our interaction term right here, extrovert times days in isolation. And the 1 just means that this variable is coded 0 and 1. So it's giving us the 1 here. That's the interaction term. If we had multiple, if extrovert was a multi-categorical variable like race, you would see a 1, 2, 3, whatever there. And that would be the interaction term for each one. So, you know, if we were using our other variables, so it would be like a 1, and that would be Asian times days in isolation. If we had a 3, that would be Black times days in isolation. I think we were a 4 for Hispanic and days in isolation, and 7 was white. Well, we would have a reference group, so white would probably be the reference group. But anyway, so that's how that would look in Stata, and you'll see more of this, don't worry. And then our constant, our intercept is just at the bottom there. So when we run this in Stata with the shortcut, it's really nice and easy because we don't have to compute anything. We just tell Stata what variables are the continuous variables, what variables are not continuous. We put our two hashtags in there, and it does everything for us. Now, what about our probing, right? So remember when we interpreted this? Let me go through the interpretation again just for the practice, right? So we look at our overall model here. So we can say our F is much bigger than 1, so the whole model is statistically significant. These variables are explaining 96% of the variance in stir craziness, which since this is fake data makes a lot of sense. For every 1 day in isolation, your stir craziness increases by 0.416. Extroverts on average are 1.0807 points higher in stir craziness than our introverts. We'll skip down to our intercept and say that introverts, our reference group, start out in sturdy craziness at 2.2866. And then we have our interaction term, which again, I only look at whether it's statistically significant. It is. So let's probe it. Okay, so here's our new line here. Probe your significant interactions. All right, so I'm going to copy this code right here. And look at this as a progression. Data short. And then we are going to probe the interaction. All right, so this syntax is trying to set it up so that you can kind of see easier what's happening. So it's easier to put your continuous variable first, so days in isolation, and then your categorical variable second. Now, we have to change these numbers into meaningful numbers. So let me go back to the slide. This is where you have options. Now, when you are probing your interactions, you want to put, we go all the way back to, where is that? You want these values here to be as some logical numbers. First off, you want them to be in the actual range of the data, but you want to kind of get a sense of like where's the high and the low values. So there's a couple of different ways to choose what your high and your low values are. The two main ones are going to be saying, okay, 1 standard deviation below the mean and 1 standard deviation above the mean. And I believe that when I did process, this is 1 standard deviation below the mean in days in isolation and 1 standard deviation above the mean in days in isolation. So that's how we end up with like 3 point something and 14 point something here. We're just choosing some convenient numbers to put as our top and our bottom, so that we know that when we're plotting these graphs, they're actually within the range of most of the data. That's all we're doing. So when we get to here, it says replace with 1 standard deviation above and below the mean. We have to calculate that. So the easiest way to do that is to just summarize days in isolation. I always do this. Days in isolation. This data is going to give us a mean and a standard deviation. So what I like to do, I think we can just do display. Yeah, I'm trying to remember what this data was. So we display. This is the mean plus 1 standard deviation. That's the mean minus 1 standard deviation. When I run that, this data gives me 2 numbers. The mean minus 1 standard deviation is 3.478. So I'm going to put that here as our low end. And then the mean plus 1 standard deviation is 14 point something. And I'm going to put that as our high end. Okay. So what I just did is we want to probe the interaction at 1 standard deviation with points that are 1 standard deviation below the mean and 1 standard deviation above the mean on our continuous variable. So I told Stata to give me the mean and the standard deviation for our continuous variable, which is days in isolation. And then all I did is I used this display function, which is just a calculator, to add the standard deviation to the mean and subtract the standard deviation to the mean from the mean. And then I put that into my plot here. So we have points to point for days of isolation. We also need points for our moderator variable. Since extroversion is a dummy variable, we have 2 points already, 0 and 1. It wouldn't make any sense to plot us in any other points, so that's what we're going to stick with. All right, now when we run these 2 lines of code, it's going to do 2 things. The first is that it gives you a bunch of numbers. These are the value of stir craziness at each of these numbers. So let's just kind of show you. So when days in isolation is at 3.45 or 48 or whatever this number is, so this is one standard deviation below the mean on days in isolation. 4 extrovert equals 0. That's our introverts, right? So this is the low days in isolation for our introverts. This is the low days of isolation for our extroverts. This is the high days in isolation for our introverts, high days in isolation for our extroverts. So that's where these numbers are getting plotted at. And then these numbers here, the margin, that's the actual stir craziness at each of those points. Okay, and then this is going to give us a plot, which is this plot right here. So let me show you first the margin so that you can actually see that it's the actual numbers, right? So this is 3.4, these guys, this is about 9.2, you know, this is the 8.4 right here, and that's the 25.7, right? So these numbers correspond directly to this plot. These numbers represent high and low on days in isolation, and high and low are extroverts and introverts. Okay, so that's the margins plot, which is the official name for this, or our interaction graph. You can see, if we go back to a slide, this plot is the same as this plot. This is our interaction graph in process, and this is our interaction graph in Stata. That's how we get that in Stata. And so now let me show you, okay, so those are the steps in Stata. Just to review what I did, I skipped right down to running the regression with our Stata shortcut here. I figured out what one standard deviation below and above and below the mean was on our continuous variable, and then I plugged that into our margins plot, and then I created the margins plot. So that's Stata. In process, you have to do even less, right? So process, there's a macro. Let me go to SPSS for you. We'll go to our regression here. This might already be set up. Let me reset it for you so you can go straight from 0. All right, like we've done before, we put our dependent variable in the Y. Our independent variable, our continuous independent variable, is going to go in the X. And now we're treating extroversion as our moderator. Now, because extrovert is a dummy variable, we don't need to do anything with this multi-categorical over here. We really don't need to do anything at all, except tell process to give us some output for plotting this. So we've got our stir craziness, days in isolation, our extrovert. Our interaction model is model 1. Oh my gosh, I got the book right here. Let me show you. We were using model 4 for our mediation. Model 1 is moderation. Right there. That's moderation. Okay, so that's our model 1. So that's what we're going to be using in process. What we're going to do is click on our options. The option we want here, generate code for visualizing interactions. That's how we're going to get this nice plot, except with the plot I showed you before. Here's where you get your choices. You can plot it at 16th, 50th, and 84th percentiles, or you can plot it 1 standard deviation above and below the mean. In the Hayes book, he's going to go into why you might want to choose this option instead of that option. They're really going to look very much the same. You know, 1 standard deviation above and below the mean is pretty standard, so we're going to go with that. I click OK. It's going to run. And here's the output, some of the output you saw before. Gives us the model, we check our variables, make sure they're right. There's that regression equation. Process gives us a little bit more information. It basically tells you what variables are in the interaction term. And then it tells you what the significance level of that interaction is. This is the R squared change. So this is like as if you had run a hierarchical regression, just adding that interaction term, this is how much it would have changed. The R squared would have changed. And this p-value is always going to be exactly the same as that p-value right there. And then what it's going to do is going to give you the actual slope for extroverts, which is 1, and introverts, which is 0. This is where I had pointed out before, if you wanted to know how to interpret the number for this, it's how much the slope changes for each, for the group that's coded 1 compared to the group that's coded 0. And you can see that most directly if you look at the what process calls these conditional effects, right? So in our reference group, our introverts, right, this is the effect of days in isolation on stir craziness. Notice it is exactly the same as the slope of days in isolation. And then our slope for our extroverts is going to be this number right here, days in isolation, plus the interaction terms. And that's how you get that 1.468. So that's just a little bit about where these numbers come from in process. And then process gives us the code to plot our interaction. So you can just copy this, run over to your syntax window, paste it in, copy it all, run it all, and then you're going to get this interaction graph, which is the one I showed you before. And it's not going to let me do a fit line, so I have to do that line. And that's that. That's how you get your interaction graph in process.